Today's discussion is all about introduction to logarithm. So what is a logarithm? Logarithms are rockin' rhythms. A logarithm is an exponential in disguise. How are they related? Let's say base b of y is equal to x means the same thing as y is equal to b raised to x. For example, we have log base 3 of 81 is equal to 4, means 81 is equal to 3 raised to 4. Recall when we talk about exponentials, b is greater than 0 and b should not be equal to 0. Notice this one, on how the numbers 3, 4, and 81 place from logarithmic to exponential function. In both cases, the base is b.
Let us know about the wonderful world of logarithms. So we already know how to take exponents. If I were going to say 2 to the 4th power, how's that? That is 2 multiplied by 2 multiplied by 2 multiplied by 2, or simply repeatedly multiplied 4 times. And that is equal to 2 times 2 is 4, times 2 is 8, times 2 is 16. For what about creating things in the other way? What if we essentially know that we get 16 when we raise 2 to the some power? We want to know what that power is. So for example, let's start with 2, and I say raise to x to some power equal to 16. Well, we are just figured that out. In that case, x should have to be 4. And this is what logarithm is fundamentally about, figuring out what power you have to raise to get another number. Now the way we would denote this with logarithm notation is log base 2, so log base 2 of 16. So of 16 is equal to x. This and this are equally or equivalent statement. This is saying that take 2, the power I get is 16, and this is saying what power do I need to raise to 2 to get 16, and that is x is equal to 4. Now let's have another example. So let's say we have log base 3 of 81. So in this logarithmic function, how should we evaluate this one? So that would be log base 3 of 81 is equal to x. So if we're going to write this one into exponential equation or function, it would be 3 raised to x is equal to 81. That means with these two equations, from algorithmic into exponential, we're going to find the value of our x. So we just need to know what number or power to be raised to 3 to get the value of 81. Same with the other side, 3 raised to x, we need to get the value of x so that we get 81. So what power do we need to get the value of 81? So let us solve. 3 times 3, that is 9, times 3, that is 27, and times 3, that is 81. Okay, so that means 3 raised to 4 is equal to 81. Therefore, the value of our x or log, the value of our x is 4. So that would be log base 3 of 81 is equal to 4. And since 3 raised to 4 is equal to 81, so that the answer is 4. So we could say that log base 3 of 81 is equal to 4. Now let's try some larger number. For example, we have log base 6 of 216. So how would we evaluate this one? In this case, you should ask yourself what power we should raise to 6 to get 216. So let us try 6 times 6 is equal to 36. And 36 times 6, that is 216. That means 6 raised to 3 is equal to 216. So log base 6 of 216 is equal to 3. That's it. The answer is 3. So let's have another example. So for example, we have log base 2 of 64. So how are we going to evaluate this expression? First, of course, think of a number or power that we should raise to 2 to get a 64. Then let's try it. Okay, so we have 2 times 2 is 4, times 2 is 8, 16, times 2 is 32, times 2 again is equal to 64. So that is 2 raised to 6 is equal to 64. Then, of course, we have 2 raised to 6 and that is equal to 64. Therefore, log base 2 of 64 is equal to 6. So let us have another example. What if we have log base 100 of 1? So again, we have log base 100 of 1. So what do you think the power that we should raise to 100 to get the value of 1? Do you have an idea? So to determine or to solve for this equation, let us first rewrite this algorithm function to exponential function. So this would be, we have 100 raised to x is equal to 1. So now we're going to determine the value of x, and that is x is equal to 0. How is that happen? Why 0? Because we have what do we call this? Our log base 100 of 1 is equal to 0 simply because any number that raised to 0 is equal to 1. So the answer is 0.
Now, let's talk about logarithmic equations and inequalities. This section is about solving logarithmic equations or simply equations with logarithms in them. One of these is equation in which every term is a logarithm. The other is equations in which all but one term in the equation is a logarithm and the term without the logarithm will be a constant. This equation will require us to assume that the logarithms in each equation will have the same base. Note that we can only plug positive numbers into a logarithm. Now let's start off by looking at equation in which each term in logarithm is all the base on the logarithms are the same. In this case, we will use the fact that if log b of x is equal to log b of y, then x is equal to y. Here are some examples. Yay! Now, let's move on to logarithmic inequalities. Logarithmic inequalities are inequalities in which one or both sides involve a logarithm. The key to working with logarithmic inequalities is the following fact. If b is greater than 1 and x is greater than y, then log base x over log base b is greater than log base y over log base b. Otherwise, if 0 is less than b less than 1, then log base b of x is less than log base b of y. Of course, the base of logarithm cannot be 1 or non-positive. More importantly, the converse is true as well. If b is greater than 1 and log base x over log base b is greater than log base y over log base b, then x is greater than y. Otherwise, if 0 is less than b less than 1, then x is less than y. Hi there! I'm teacher Tiffany and I will be discussing basic properties of logarithms. At the end of the lesson, the learner is able to apply basic properties of logarithms and solve problems involving logarithmic equations. Let b and x be real numbers such that b is greater than 0 and b is not equal to 1. The basic properties of logarithms are as follows. Now let's have an example and identify the following property of logarithm.